Hi guys, today we're doing advanced solution equilibria. Now, our syllabus outcome is predict the formation of a precipitate given the standard reference values for KSP. Now, just some revision questions. Do them in your book first, pause the video until you've done them, then come back for the answers. So, the dissolution of an ionic salt is an equilibrium process at saturation. So when no more will dissolve, we get a dynamic equilibrium established, where some dissolves and some goes back into solid. The solubility product, KSP, is a measure of the maximum solubility of an ionic salt. And solubility is commonly given as grams per 100 mils and needs to be converted before it can be put into the KSP equation. So remember, KSP is just like our normal K equations. We use concentration in moles per liter. And so we have to convert grams per 100 mils to moles per liter before we can put it into the equation. Now, the advanced solution equilibria. So today's lesson will allow us to calculate solubility of a salt based on the KSP. It involves using an ice table with an unknown concentration, and very similar to the KEQ questions involving finding the concentration. However, we have the added step of finding solubility. So we need to do that conversion, that moles per liter to grams per 100 mils. Now, we'll get straight into it. We know how to use ice tables. We should know how to calculate concentrations at equilibrium. So what we're going to do is we're going to jump straight in with an example. So determine the solubility in grams per 100 mils of lead 2 sulfate. Now, lead 2 sulfate, we're given no more information than that. But we actually do have some information on our formula sheet. Okay, that's it. That's all the information you're getting from me. It's also all you need because, like I said, the information is on the formula sheet. Finding the KSP, it's the front page of your formula sheet. Down the bottom, there's a table of KSP values. If it's not given to you, it will be on the formula sheet. You're not expected to remember anything. We're hoping you need to be able to apply the knowledge that you know. You don't need to remember KSP values. They should be there. So having a look at that, we see that the KSP for lead 2 sulfate is 2.53 times 10 to the negative 8. We can then set up an ice table. So we know that at the beginning, we only have lead 2 sulfate solid. And it dissociates into lead 2 plus ions and sulfate ions. Okay, 1 to 1, nice and easy. So initially, there's going to be no ions because we've added a solid, it hasn't dissolved yet. Okay, the lead and the sulfate will change, and they change in equivalent amounts because they're 1 to 1. And so therefore, at equilibrium, it's just going to be X. Okay, so the equilibrium concentration is just going to be X for both lead and sulfate. We then need to write out our KSP equation. So just like our K equation, write out our KSP equation. So for lead sulfate solid in equilibrium with lead 2 plus ions and sulfate ions, we get lead 2 plus concentration times sulfate concentration. Nice and easy. We then substitute in our values. So at equilibrium, lead was X, sulfate was also X. Gives us X squared. We have a KSP value of 2.53 times 10 to the negative 8, which is X squared. So take the square root of both sides. We get X equals 1.59 times 10 to the negative 4. Now, that's not the end of the question. That would be if we needed the molar solubility. Okay, so if we needed moles per liter, that's it. That's what we use. We now need to convert that to grams per 100 mils. So typically the question will ask for grams per 100 mils or moles per liter. You have to read it to find out what it's asking for. So in this case, it was grams per 100 mils. So we have 1.59 times 10 to the minus 4 moles per liter. Now that's 1.59 times 10 to the minus 4 times the molecular mass of lead 2 sulfate. So that's lead plus sulfur plus 4 oxygens. That gives us 0.0482 grams per liter. Okay. Now we want grams per 100 mils, so we're going to divide that by 10. Okay. So we get 4.82 times 10 to the minus 3 grams per 100 mils. And that's our solubility in grams per 100 mils of lead 2 sulfate. Now, example 2. Let's do another one. Determine the solubility in grams per 100 mils of silver phosphate. So this one's a little bit different. So silver phosphate, looking on our formula sheet, I'm pretty sure it's there. KSP of silver phosphate is 8.89 times 10 to the negative 17. How do we do it? Same thing, we set up an ice table. Now, what's the formula for silver phosphate? Well, silver has a +1 charge, phosphate has a 3 minus. So it's going to have to be balanced to Ag3PO4, which then dissociates at equilibrium to 3 silver ions plus 1 phosphate ion. Now, what this means for our ice table, initially it's going to be 0, but our ratio is now 3 to 1. So silver is going to go up by 3x, whereas phosphate goes up by x. Okay, so for every mole of silver phosphate that dissociates, we get 3 moles of silver plus and 1 mole of phosphate. Okay. Now, we need to do our KSP equation. Now, if we have a look at our formula, so for our reaction, silver phosphate dissociates to 3 silver plus phosphate. We're going to get the KSP equation of silver cubed times phosphate. Okay. Now, we have to substitute in our values at equilibrium, which are our x values. So for silver, it's 3x, and for phosphate, it's x. Okay. Now, super important is to watch this cubed. Okay, so 3x cubed is not 3x cubed. Okay, it is 3 cubed x cubed. Remember that. The cubed goes to both things within the bracket, the 3 and the x. So what we end up with is 27x to the 4. Okay, so we have 3 cubed, which is 27, x cubed times x gives us 27x to the 4. Now that's equal to our KSP value. We then solve for x. Divide by 27. Take the 4th root, which gives us x equals 4.26 times 10 to the negative 5. Now, that would give us the number of moles per liter of our compound that dissolves. Okay. We then need to find the solubility in grams per 100 mils. So again, we take our solubility in moles per liter, we convert those moles to grams by multiplying by the molecular mass. So in this case, 3 silvers, so 107.9 times 3, plus 30.97, which is phosphorus, plus 16 times 4, PO4. Okay, it gives us 0.0178 grams. And that's in per liter, so per 1,000 mils. How do we get it to per 100 mils? We divide it by 10. So we get 0.00178, or 1.78 by 10 to the negative 3 grams per 100 mils. So, in summary, to calculate the solubility of a salt given KSP, we need to use an ice table. Always use the ice table assumption that if x is much less than y, then y minus x is approximately equal to y. It's not as such of a big deal in this one, because we very rarely get the common ion effect, but if we do have to do that, we use that assumption. Solving for x in an ice table gives you molarity, but solubility is generally measured in grams per 100 mils, so we need to convert the units. And that is all for today. Thank you.